In our last lecture on process models, we left off after we discussed process flows. We're now going to move on to prescriptive process models. These are process models that advocate for a very orderly approach to software engineering. So let's get into it.
Okay, so where we left off last week was discussing prescriptive process models. And these are models that have a very strict or rigid or orderly approach to software engineering. So activities and tasks occur sequentially within defined guidelines for progress. And we call these prescriptive as they prescribe a set of process elements and process flows. So this really rigid structure leads to a few questions. So the first one is, if prescriptive models strive for structure and order, are they appropriate for a software world that thrives on change? In that first week, we talked a lot about change and how it can impact software development. So the models we're going to be taking a look at are very strict and rigid. So that means they don't really handle change that well. So the one question that comes up are they going to be appropriate if that's the case? But then on the other side, if we reject these traditional process models and replace them with something less structured, like agile models that we'll be talking about later, do we make it impossible to achieve coordination and coherence with software work? So if we throw out structure and all this like heavy documentation, are we still going to be actually able to produce the software while we know what we're doing? Things like that. So there isn't any real easy answers to this. And the best method is, as I've mentioned before, is to adapt these processes for your needs. If you have a small project with a small team like just you, maybe some of these prescriptive process models will make sense if you don't have a large stakeholder. However, in other cases where things are rapidly changing, the industry's changing, the technology used are changing, maybe an agile approach will be better. So let's get into it. So the first process model, and probably the most famous one, is the waterfall process model. And this is called the waterfall model because you can kind of see that each activity flows into the next, falling downwards. So we go from communication to planning to modeling to construction and deployment. This is called the classic life cycle. But there's some problems with this. Maybe you can see it right away by just looking at it. And that is, there's not really any feedback flows between any of these activities going backwards. There's no way to sort of go back if you found an error. So you may have done the communication activity, found all the requirements you need, and then moved to planning, and then got to modeling. And then while you're modeling, you realize that maybe a requirement doesn't make sense, or something that you planned isn't quite going to work out. It's going to take a lot more time. There's no way to actually go back. The second big issue is stakeholder involvement is only at the communication phase and the deployment phase. That means that stakeholders are only going to really be involved at the beginning of the project and the end of the project. This can be a big problem because it's not always clear what the stakeholders actually want, what the requirements are. And by the time you get to deployment, maybe you made something that isn't really what they wanted. The upside is it's very ordered and very simple, so it's easy to understand. So, while it's usually considered an anti-pattern almost, something that you shouldn't use, it can still make sense for individual projects, maybe where you're the only person working on it and you're the only real stakeholder, like a personal project. So just to go over those pros and cons again, it's easy to understand and plan. It works for well understood small projects. Maybe if you're on a small two-person team making just a simple static web page, something like this would make sense. But even then, you'd probably want more feedback from the stakeholders. Analysts and testing are straightforward, but there are some cons, as we mentioned. Doesn't accommodate change well, testing occurs late in the process, and customer approval is at the end. So it means you could be in big trouble if you get to the end and they don't approve. You're going to have to restart the whole process. Another common process model we sometimes see is the V process model. This is a variant of the waterfall model, where we go from requirements modeling, architecture design, component design, code generation, and then we get after the code generation point, we usually have some kind of executable software, and we start going upwards. Now we're going to do testing and analysis on the software that we created to see if it really meets the requirements, if it passes our tests. So we do things like unit testing. That's where we're testing small individual components of the software. Integration testing, how those components fit together. System testing, and then acceptance testing. Acceptance testing would be, does the customer accept what we've created? Does it meet their requirements? There is a big problem here. Perhaps you can see it. And that is this actually different than the waterfall model? I mean, it does a good job of showing how these different testing steps connect to each activity, but Really, it's just the waterfall model that's been broken in half and bended upwards at that last stage before deployment. So that means it really has all of the same issues as the waterfall method. So let's go over those pros and cons. So the pros remains easy to understand and plan, just like the waterfall. It works for well understood small projects. The analysis and testing are straightforward, and it is at least a good way to verify or visualize how verification and validation actions are applied to earlier engineering work. The cons is there's no fundamental difference between the V model and the waterfall model. The waterfall model is just simply being split and folded up right between coding and deployment, and it doesn't accommodate change as well. Again, you're only talking to the stakeholders at the beginning and the end, so you're going to have a big problem if they don't accept it. And testing is only occurring at the end after we've made the software. In an ideal model, we should be testing all the way through. And like I said, customer approval is at the end. So the next model is the prototyping process model. So the prototyping model begins with communication, collecting initial requirements, and outlying areas where further definition is necessary. Prototyping iteration is planned, with quick models and designs created, focus on aspects of the software visible to users, and design work leads to a construction of a prototype. Prototype is deployed, evaluated by stakeholders, who provide feedback to further refine requirements in design. So the idea here is that you're putting out quick prototypes and getting them back to the stakeholder right away so that they can take a look at it and see if this is what they want. We often find that during the communication phase, when we're gathering the requirements, what the customer or the client says that they want isn't really what they want. And they don't really understand what they want until they actually see it in front of them working. So having a quick plan, quick modeling, and then construction of a prototype really quickly, and then getting it to the stakeholder means that they can see right away what it actually is looking like, that what they're requesting, and then they can make changes to it. So this would be an example of a process model with iterative flow. So each time we're going around this loop, we're making a new iteration of the software, a new prototype. The pros are it reduces impact of requirements changes. The customer is involved early and often. Each time we go around that cycle, we're getting the customer involved. And it tends to work well for small projects, and it reduces the likelihood of project rejection. Works well for small projects or projects that can be broken up into components, so your prototype can focus on a specific component or adding a specific requirement each time. For really large, complex projects, it can be a bit complex because you might need a lot of different components working before you can actually have a prototype that means anything to the stakeholder. The other issue is getting those stakeholders involved may cause delays. You're going to have to schedule meetings for them to show them software and things like that. So you might have time where you're just waiting on them to give feedback. The other issue is that there's sort of a temptation to ship the prototype. So when the customer sees the prototype, they're like, oh, yes, this is what I want. And even though you may only really have the GUI mocked up and coded, you don't really have any of the back end stuff working. And they'll consider it to be done. They don't really have an understanding of all the stuff in the back end that has to be completed. The other big issue is that you lose a lot of work if you have to throw away a prototype. Sometimes a prototype just isn't working out, and it can be hard to actually decide to throw it away. So this can go two ways. It can be bad if you throw it out because you lose all that work you've done and have to start over, but it can also be bad if you choose not to throw out a prototype that needs to be removed and refactored or something like that. It can also be hard to plan and manage. You don't really know when this is going to end, and you don't really know how that prototype is going to go necessarily. The next one is the spiral process model. This is another evolutionary approach, and it also uses sort of prototypes and iteration. So it couples the idea of that iterative nature of prototyping with the controlled and semantic aspects of the waterfall method. So we're trying to sort of get the best of both worlds here. We want that controlled and well understood method while still getting those frequent prototypes that we can get out to the stakeholders. It's also a very risk-driven approach. Remember, risk is sort of like identifying, or risk management rather, is sort of identifying potential problems that could come up in the planning stages, development stages, any of the real stages, and trying to avoid them before they happen. And this model actually has risk management built in, where you're constantly considering what kind of risks are going to be coming up. So part of that risk-driven approach is that prototyping becomes risk reduction method. So you're building prototypes as you go along, so there's always some code there, and you can show this to the stakeholder as you go, So that means you're getting some feedback from them to make sure that you're building what they actually want. So it starts at start in this diagram near the center, and you spiral outwards. You start with communication, that's getting the requirements, do planning, estimating how long this is going to take, scheduling, risk analysis, what are the potential problems going to be. Move on to modeling, you do the analysis and the design of the software. That's like sort of making models like UML that we'll get into. And then we move into construction. We're actually making the code, doing the tests, and then we move into deployment. So that's where we actually give it to the customer, get their feedback. And this is at the point where a prototype is released. And then we sort of get further out in the spiral. And the reason why we're getting further out from the center is as we go out from the center, we get a more complete system. Prototype becomes more complex and it becomes more finished. So as we get further out from the center, we get a more finished project, hopefully, but there's also more and more risk. It's getting bigger, more time's put into it, and things like that. So the pros are there's lots of customer involvement. Development risks are managed because that's part of the phase every time we go around that spiral. It's suitable for large, complex projects, and it works well for extensible products, especially if you can break it up into smaller parts. Cons are risk analyst failure can doom the project. So if you don't properly find those potential problems, the project may be hard to manage because, again, we don't really have a clear ending point. We don't know if we're ever going to end. Is the customer ever going to accept it as a final thing? And it requires a pretty good development team that knows what they're doing and is familiar with the process. The next one is the unified process model. And this is a use case driven, architecture centric, iterative, and incremental model. And it's closely aligned with the unified modeling language. That's something we're going to be getting into soon in the course, but it tries to make big use of those UML diagrams and models during the modeling stage, as well as other stages like even requirements gathering and planning. It consists of a number of phases that map to those generic framework activities that we've been talking about, and it does that iterative nature. So as we're going around that circle, we're making a prototype or some kind of release that can be evaluated by the stakeholder. Now we can see those generic framework activities here: communication, planning, modeling, construction, and deployment. But the unified process tries to have them overlap a bit or join them together into phases it calls inception, elaboration, construction, transition, and production. Inception encompasses customer communication and planning phases, capturing requirements as a set of use cases, and formulating an initial architecture for software outlying major subsystems. Elaboration refines and expands upon preliminary use cases and architecture from inception to create use case, analysis, design, implementation, and deployment models. Construction. Using these models, software is created that makes each use case operational for end users. As components are created, they're tested individually and integrated to the whole. So the next activity is transition, and this is where the constructed software is delivered to customers and feedback is collected, and software teams create the necessary supporting documentation. Recall that the unified process model is really big on the documentation, so it encourages things like user manuals, installation guides, and so on being created. And all this documentation results in usable software increments. So it's not so much as a prototype as it could be actual software that the customer can use. This makes this model really good for more of a maintenance type system where, like, for example, maybe you're working on OWL, you want to add new features to that learning management system. Following this process would be a good way because each time you're going around the loop, you might actually be producing something that's deployable and usable. And the last one is production. So outgoing use of software is monitored, support is provided, and defect reports and change requests are submitted to shape the next increment or update to the product. So let's talk a bit about the pros and cons. So big pro is we get a lot of quality documentation. That's a big emphasis of this model. We really care about the documentation. So that means we're going to be producing a lot of great things for the users: user manuals, installation guides, and very detailed modeling. The downside of that, however, is that documentation isn't really great if you're never going to use it or look at it again. So some of the agile methods that we're going to be looking at in a bit try to get away from this overuse of documentation and try to emphasize only using documentation that's needed. So the unified process model is big on documentation. So if that's not something you actually need, that might not be a pro. But if it is something you need, like if you're supporting a living system like OWL, that would be a plus. Another thing is we have continuous customer involvement. In the cycle, we're always producing these increments to the customer, so they're getting constant feedback about what they like about it, what they don't like about it. And that means it also accommodates requirements change as well, because you're in constant contact with the customer. So it works well for maintenance projects, as I mentioned. So things like living systems like OWL, or something that you're sort of adding increments to as you go. The cons are the use cases are not always precise, so they might not be super detailed. The overlapping phases, like inception, elaboration, and so on, can also cause some problems. If you're doing communication and planning at the same time, you can have a problem if the requirements are changing as you're trying to plan it, or if you're trying to plan it as you're modeling, things could change and cause issues. Now, these have just been a few of the prescriptive process models. There are many, many more, and I'm sure people are coming up with more all the time. But all of these really high structured models tend to share the same problems, which is that they don't handle change well. They're still appropriate, though, for some cases, like well understood projects, or for very, very large teams, very large projects, or really high risk projects.
That's all I have for you in this video on prescriptive process models. In our next video, we're going to be taking a look at more agile process models. These are a lot less rigid and a lot more flexible to changing requirements. So if that's already posted, take a look at it now.